In the second episode of Relations and Functions, I'm going to cover some terms, two more terms that relate to, relate, I told you that was an important term, that relate to the X and Y value and also the input and output terms that I used in episode 1 on Relations and Functions. These terms are, all of these terms, the X, the Y, the input, the output, and the new ones today that I'm going to talk about are all synonymous with each other. It's kind of like when you're talking about different kinds of animals, like a mountain lion. A mountain lion can also be called a cougar. They're the same animal, although that's probably not the best example to use right here, especially with middle school students. Let's see. What about maybe like a TV? TV is short for television. Television is also termed like the tube, like what's on the tube, the box, the telly, which they say in the United Kingdom. So it has different words that mean the same thing. And that's the way these relations and functions are. When we're talking about a set of ordered pairs, a relation, it can be termed the X value and Y value, input and output. And today I'm going to teach you about the domain and range, which really you should already know. It's just different terminology. That's it. So I'm going to cover those two terms today, domain and range, and I'm going to show you in this next slide what they are. Here are 3 different ways that it can be represented: the X value and Y value, the input, the output, and the domain and the range. The X value in order pair is the same as an input. The X and the input are exactly the same as the domain. The Y value is the same as the output, and the Y and the output are the same as the range. This is a table of ordered pairs. It's a relation. But this time, instead of an X and a Y, I used a D and an R at the top of the table to represent the domain and the range. Here are the 4 ordered pairs. Is this relation a function? The answer is no. This is why. I have the same domain twice. However, I have a different range for each of those domains. If you recall the soda machine, I just hit the same button 2 different times and got out a different soda. Here, I hit the one button twice, but got out 2 different ranges. Next example using domain and range. Again, I have 4 ordered pairs in this table. Is this a function? It is. Even though I have the same domain 2 different times, I'm still getting out the same range. To reference the soda machine, if I hit the same button, I should get out the same drink. I want you to identify the domain of this set of ordered pairs. Since the domain is the same as the X value, all I need to identify is the first number in each ordered pair. So the domain in this relation is 1, 2, 4, and 7. You may have noticed that in the set of ordered pairs, the domain of 7 comes before the domain of 4. However, I listed the 4 before the 7. This is because when we list the domain, we list it in chronological order from least to greatest. Let's identify the range of this relation. And since the range is the same as the Y value or the output, I only need to identify the second value in each ordered pair. The range of this relation is -1, 2, and 6. There are 2 things I want you to notice. The first one, again, is that I listed the numbers in the set from least to greatest. The second thing I want you to notice is that even though I have a 6 in the range that's repeated, I only listed it once when I listed my set for the range. So when listing the domain and range, you list them from least to greatest, and you only list each value once. This next thing that I'm going to show you is called mapping. It's just another way to demonstrate or show the relationship between the domain and range, X and Y, input, output. And it's an appropriate term, I guess, considering that GPS systems use, they're a mapping system that uses the coordinate plane and the relationship between the X and the Y's to pinpoint a particular location. So again, it's called mapping, and let's go to it. Here I have a domain and a range. So I have a set of ordered pairs. The ordered pairs are identified by the rays. Since I have a ray going from the 0 to the 1, that means I have an ordered pair of 0, 1. My next ordered pair is 0, 3. Then I have an ordered pair of 1 and 4. My last ordered pair is 2, 2. Now that we've identified the relation for the domain and range, is this a function? No, because I have two different range values for the same domain value. So if I push that 0 button and get a 1, I expect to hit the same button again and get a 1, but I hit the same button again and got a 3. Here is our next example using mapping. Let's identify the relation. There's a ray pointing from 0 to 2, so my first order pair is 0, 2. My next order pair is 1, 4. Then 2, 1. And last, 3, 4. Is this a function? It is, because you can have the same range value for two different domain values. Remember, it's possible to get the same soda by hitting two different buttons on a soda machine. Let's review quickly. Can you identify the domain, the range, and whether or not this relation is a function? Remember, you can pause the video at any time. The domain is 2, 3, and 4. And notice I put it in what we call set notation. The range is 1, 2, 3, 4. This is not a function because I have two different range values for the same domain value. So this is all we're going to use to determine if something is a function or not on a coordinate plane. This is called the vertical line test, or in this case, a vertical line segment test. If our line touches, intersects, or crosses through only one point at a time, we can determine it is a function. If, however, our vertical line touches more than one point at any given time at the same time, it is not a function. Now, to determine if this relation or these points on the graph are a function or not, I can use that vertical line, that blue vertical line to the right. I am going to drag that so-called vertical line straight across the graph over each point. Here, it's only touching one point at a time. It's also only touching one point here, and here, and here. Because that blue vertical line I used was only touching one point at a time, it indicates that this is a function. Here is the graph of another relation. I am going to use that blue vertical line again, drag it across the screen to see if it hits more than one point at the same time. Only one point here, only one point here, one point here, but now it's passing through more than one point. And because our vertical line is passing through more than one point at the same time, this is not a function. I graphed three different situations on this same coordinate plane. Can you use the vertical line test to see if any of these are functions? I am going to use that green line as my vertical line for my test to determine whether the graphs are functions or not. I am going to sweep it from the left to the right. At this point, it is only touching the blue line in one spot, the red line in one spot, and it's not touching the purple line at all. The same thing continues to happen as I move to the right with my vertical line. As I get over the purple lines, however, notice that it's touching the line in more than one location. As I continue to move to the right, my vertical line only touches the blue line or the red line in one spot at any given time. However, it is continuing to touch the purple line in two different locations. This indicates it has the same domain, but a different range. For instance, with the soda machine, it's like hitting the same button, but getting a different drink out each time. So the graph of the blue line is a function. The graph of the red line is a function. But the graph of the purple line is not a function.